Hi guys, welcome back to Data Every Day. Today we'll be looking at a dataset of the top female chess players and their rankings and some other attributes about them. We will be using this dataset to try to predict whether or not a player is a Grandmaster or not. Let's get started. So you can see we're importing our usual libraries, NumPy and Pandas. What would we do without them? And oh, 1 second. Sorry. Just trying to get everything ready here. Okay. And we're going to import the data using the pandas.readCSV function. And the data can be accessed right over here, file path from Kaggle, copy file path, just paste it right in, and data equals. If we take a look at it, this is what our data set looks like. So we only have 10 columns, so not such a complicated set of features, and we have a good number of training examples. So remember, we're trying to use the title column to predict whether or not a player is a Grandmaster. Now notice right now the column is not in that form. We don't have a Grandmaster column. So we're going to have to get a dummy column from this column to use as our target column. Alright, so let's start pre-processing this dataset. Let's think, what do we need to do? Okay, first of all, we see that there are a few columns here that aren't giving us useful information. Namely, the first two, the FIDE ID and the name. These guys aren't really going to help us predict whether or not a player is a Grandmaster. As far as I know. I mean, I assume the ID doesn't have much to do with how good the player is. So we're just going to drop those. Data.drop and FIDE, whoops, ID, and name. Oh, another thing. This is a dataset of women or female chess players. So the gender column is giving us absolutely no information. It will always be female. So we'll drop gender as well. Okay, and then we'll just specify the column axis and in place. Alright, let's take another look. You can see now we have 7 columns, but much more useful information. And I figured, someone might say, well, the year of birth isn't actually giving us information either. But because with something like a game, like chess, it evolves over time. And so it's possible that the level of skill required to be Grandmaster is going to go up the older you are. Just a possibility, so I'm going to leave year of birth in there. Now we'll handle missing values. You can see we have not a number of values in there, so I'll make this a header 2, missing values. And we can check the total number of missing values using the isNull function. And that'll give us a matrix of true and false based on whether or not a given value is missing. So this is a missing value, this is a missing value, this is not a missing value. Then we can sum over that matrix to get the total number of missing values in each column. And here we go. So these two have no missing values, but you can see there's a substantial amount of them in the other columns. So first thing to do with missing values is figure out what are the data types here. Data.dtypes. And we can see we have 1, 2, 3 non-numeric columns. The numeric ones we can handle fairly easily. So why don't we do that one first? We'll create a list of them called numeric features, and we'll just put their names in it. So it's going to be year of birth, standard rating, rapid rating, and blitz rating. I think that's it, right? Yeah. Okay. However, the reason we're doing this, well, this doesn't really matter so much, but just to note, we're going to fill in or impute the missing values with the means of each value. But since standard rating has no missing values, I actually don't have to include it here. Because we're not going to be doing any processing on standard rating. So we have these three guys that have missing values, which is year of birth, rapid rating, and blitz rating. And we're going to try to fill in their missing values with the means of each column. So we can just write a for loop for this. For column in numerical features, so for each one of these, that particular column will now be, well, I'll just write it like this. We'll call the fill NA function, which will fill missing values with a given value. And the value we're going to fill the missing values with is going to be the mean of that column. And then we'll just set the column equal to this. Run that. Now if we take another look at the number of null values, you can see all the numerical values, all the numerical missing values have been eliminated. So we only have these two non-numeric values to worry about. As you can see, the federation one is non-numeric, but it has no values missing. Title and inactive flag are what we have to deal with now. So a good thing to do when you're going to be filling in values for categorical non-numeric columns is figure out what kind of data is in these columns. So we're going to check each one. Since there's only two of them, we can just check them like this. We'll check all the unique values inside them. And we'll do the same thing for inactive flag. And we can see title has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 unique values. But if you remember, title is actually what we're going to be using to get our target column. We want to predict whether this is the value of title for each training example. For inactive flag, there's only two values. So when there's two values, we can do a simple label encoding, setting one to 0 and the other to 1. So in the meantime, before we encode it, we can just fill the NA values with some placeholder text. So we'll do inactive flag dot fill NA again, and we're going to fill all these NANs with a new value. And if we look over here at the dataset, WI stands for woman inactive. So we can just say the missing values will be women active, assuming that if they're not inactive, they're going to be active. Okay, so now we're just going to set inactive flag. To be that. And now, if we look one more time at the null values, only guy left is title. And we actually don't have to fill in any missing values for title. Because title is what we're trying to predict, all we need to do is extract the GM column and turn it into a column of ones and zeros. So note that if we can use the pandas .getDummies function, and we're going to pass in the title column to get a dummies matrix for each unique value in that column. So for example, training example 0, if we look up at the regular data set, training example 0 has a title of Grandmaster. And training example 8551 has a title of WFM. I'm not sure what it stands for, but it's a different title. Now if we look down here, training example 0 has a 1 for the Grandmaster column and a 0 for all the others. Example 8551 has a 1 in the WFM column and zeros for all other values. So now you have a sense of what the dummies matrix is. You can realize that we can just chop off this one GM column and use the GM column here as our target column. So we can just say data, actually we'll use the pandas.concatenation.concat to concatenate a bunch of data frames together. And the data frames we want to concatenate here is data, our original data, and this GM column right here. So we're going to take the GM column from this dummies matrix and paste it right onto our data set. So to get that GM column, why don't we set this dummies to, we'll call it title dummies. I'll just type it again so we can see it again. And now we have a variable for it. So the GM column is going to be given by title dummies indexed at GM. So now it's saying we're going to take title dummies sub GM, this column right here, and paste it right on to the right side of our data set. And to specify that it's the right side, we'll just say axis 1. And that's going to be our new data. So if we look at that, you can see now we have GM on the right side, and notice that the title guy is still there. So we're going to have to drop him. Data.drop title, the column axis, and in place. Now title's gone, and we just have our target column. So fantastic. Let's just bring this here, make it nice. Okay. So what are we going to do now? We notice there's only 2 categorical columns left, and we have to convert them into numerical values. So for inactive flag, like I said earlier, it's going to be very easy to do. Also, I should note, if we look at the null values now, there are no more null values. We now have this GM column that is a 1 or a 0 in every place, and everything else is taken care of. So let's move on to encoding. Now that encoding is going to be taking these text values and turning them into numerical values so we can feed it into our model. So we can start by, okay, why don't we start with this, the inactive flag? Because if we look at it, like I showed earlier, there's only 2 values in it. And that means we can use a label encoder to convert these values to 0 and 1. And sklearn has a very nice label encoder. sklearn.preprocessing, import label encoder, and I'm just going to put that at the top of the notebook. Okay. And oh, I didn't run it. 1 second. Okay. And we can create an encoder object, which we'll call it encoder. And we can simply say data sub here, why don't I show you if we do encoder.fitTransform, the column we want, which is inactive flag. We look at that. That's going to turn this array, well, it's a series, or a slice of a data frame, into it starts off as WI, WA, 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 WI, and it becomes 1, 0, 0, 0, 1. Get the idea. So basically, WIs are going to become 1, and WAs are going to become 0, which is perfect for 1 being inactive and 0 being active. So let's actually set that column to be this encoded version of it. So that should take care of it. Look at data again now. You can see we now have a numerical column there, and the last numerical column, last non-numeric column we have to worry about is federation. And let's take a look at the unique values in federation. So that's a lot of unique values. And we want to think about it. If we were going to encode this, we would have to make a dummies matrix for using each one of these unique values as a column. Now the question is, how much do these columns actually contribute to predicting whether or not a player is a Grandmaster? And my guess is going to be not a lot, because the actual country that you're from is not going to be nearly as predictive as, for example, your ratings. Right? This is going to be a much better predictor of whether or not you're a Grandmaster than, let's say, if you're from India or Russia. So I think it's safe to just drop this column altogether, because the drawback by creating so many new features, if we were going to encode this, we would require a much more complex model. So I think dropping this should be a safe move. So we'll drop federation, specify the axis, and in place is true. And just take another look. Now we have 6 columns, but everything is numeric, and I think we're ready to train our model. So before we do that, we just have to make sure we're going to split our y and x. So y is going to be just the GM column. X will be everything except the GM column. So data.drop GM along the first axis, and actually not in place here because we're storing it into x. Run that, and we should see y should be a one-dimensional vector of, m-dimensional vector, 8,552 dimensional vector of 1s and 0s, and x will be the whole original data frame without the GM column. So what we're going to do now is scale x. Because you can see these values take on very different ranges. Inactive flag goes from 0 to 1, and the ELO rating here could take, I'm not sure what the lowest one is. If this is ranked in order, then 1800 to 2600. So what we're going to do is scale all those ranges down to between 0 and 1. So to do that, we can use sklearn's pre-processing. We can get the min-max scaler. There's a few scalars we can pick from, but I think min-max would work here. So from, and then I will just put this at the top again. Run it. Bring this down. And then we'll make a scalar object, which will be the min-max scalar. And we'll just say x will now be equal to scalar.fitTransform x. So this will fit the scalar to our x data, and then it will transform x accordingly to be scaled between 0 and 1, and it will store it back in x. However, it will store it back in the form of a NumPy array, so we're just going to convert it back into a data frame for ease of visualization and processing. So we'll say the columns are going to be so we're making a new one here, the same as the old columns. Now we look at x, it's the same as before, except now everything is scaled between 0 and 1. Every feature, every column takes on a range of values between 0 and 1. So the lowest value is automatically set to be 0, the highest value is automatically set to be 1, and then everything else is scaled relatively. Okay, so now let's train. Alright, here we'll be using a logistic regression model. Because it's a fairly simple data set, simple logistic regression should do the job. So we're going to use the train test split function, which will just help us split our data more easily, and we can import that up here again. And we're also going to import, I'll say from sklearn.linear model, import logistic regression. Okay, let's run that. Bring it back down. Now we'll split our data set into 4 different sets: xtrain, xtest, ytrain, ytest, equals train test split, x, y. Trained size is going to be 80%. We'll run that. And now we can train our model on the train sets. So we'll say model equals logistic regression that we imported before, and we're going to fit it, model.fit, to our train sets, xtrain, ytrain. Train that, and then we'll get the accuracy value by saying model accuracy is going to be, model.score xtest ytest. And accuracy of 99%. Now before we jump to the conclusion that that's really good, let's take a look at if our classes are skewed or not. It may be that very few of these are actually Grandmasters. And if that's the case, let's say 1% of them are Grandmasters. If our model predicts that the player isn't a Grandmaster 100% of the time, we'll actually get an accuracy of 99%. Because that 1% that are Grandmasters, it will misclassify, but because there are so few of them, it'll still show up as a very high accuracy value. So to get around that, we're going to get the f-score of the model. So from sklearn.metrics, import f1 score, same as f-score, and we'll bring that up here. Just run that. And to get the f-score, we're going to need an array of predictions to compare to our array of actual values, or our ytest. So we'll get yPrediction is equal to model.predict on the xtest. So we're going to make predictions based on the xtest, and then compare those to the ytest to get our f1 score. So if we look at yPredict, it's the same format as ytest. Well, this one's a NumPy array, this one is a data frame, but it'll still work. So to get the overall f1 score, we'll just say model, well, why don't we just print it? Another f string, model f1 score, and we'll get f1 score of ytest, the actual values, and yPrediction, the predictive values. And we get an f1 score of only 0.3. So this is actually a great example of a time when the accuracy really failed to show us how our model was doing. So let's take a look, one last thing before we go. what percentage of the values were actually positive class or Grandmaster. So if note that y-test looks like this, right? The actual values. If we sum over it, we'll get the number of positive examples. Only 11. If we look at the length of y, this is the total number of training examples. So total number of Grandmasters, total number of training examples. If we divide, we'll get the percentage of Grandmasters in the data set. And as you can imagine, very low. This is 0.1%. So this guy is actually showing us nothing, right? Model accuracy means nothing here. But the F1 score is telling us a lot more. And so our model is not doing a very good job, right? Because this would, we'd like this to be as close to 1 as possible. And this is a combination of the precision and recall scores. So I'll just print this to make it nice. Percent positive examples. Actually, percent Grandmaster. Okay, so so I think, yeah, this was a pretty good video for realizing a few things. Like we thought we had a good, well-performing model, but it turned out to not be performing very well. So we would have to do some further testing and try to get maybe a better set of features or a better model itself to try to get a better value. So thanks so much for watching today's video. If you liked it, make sure to subscribe, hit the bell, and leave a comment below with any suggestions you might have for the channel or for the video, or any if I made any mistakes or anything. I'd love to hear about that. So thank you so much. I'll see you guys tomorrow. Have a great day.